our triangle angle sum theorem, and you guys probably already knew this, but if you add up all the angles in a triangle, it's always 180. It doesn't matter if it's an itty bitty tiny triangle or if it's a triangle the size of the planet, it's still 180. And we can use that to find missing angles. So if you go in your packet, I actually did this backwards. You have 4-2 practice, which is page 46, and then when you turn it over, it's page 45. Somehow I messed it up and got them printing backwards. So page 45 is actually in the back. So go to page 45, and you'll find that tiger pennant.
It looks 47, 48.
Yeah, it's like the whole rest of the packet. I don't know what happened. So we've got all three of these angles are going to add up to 180. So to find angle 1, you subtract the two angles you have from 180 and you get the missing angle. So 180 minus 80 is 100, minus 70 is 30, minus 3 is 27. Easy? Okay, and then angle 1 and 2 have those marks that show me that they're the same, zero marks. And so I'm going to subtract 146 from 180, and I'm going to get 34. And then angle 1 and 2 are equal, so I'm going to divide that by 2. So each of these would be 17 degrees. We'll use the fact that triangles add up to 180 and our vertical angles. So if we look at this triangle first, we can find angle 1. So angle 1 is going to be 180 minus 40 and 85. So it would be 180 minus 85, that's 95, minus 40 is 55. So we have 55. And if angle 1 is 55, what's angle 2? 55. And if angle 2 is 55, I can find this triangle, find angle 3. So I do 180 minus 55 and 55. 55 and 55 is 110. 180 minus 110 is 70. So this is a theorem that is kind of a shortcut for finding angle measures. You can still find them using the 180 degree thing, but this is kind of a shortcut. And first, to use the theorem, you have to know what exterior angles are and what interior angles are. So the exterior angle, if you extend the side of a triangle in a line, a straight line, you form an exterior angle. And so angle 1 is an exterior angle. It forms a linear pair with the vertex. So if I had another line, let's say if I extended it this way as well, angle 5 would also be an exterior angle because it forms a linear pair. What would not be an exterior angle is that x, because it's a vertical, not a linear pair. So I could say angle 1 is an exterior angle, or I could say angle 5 is an exterior angle, but not this x. Okay, this is a vertical angle. So the remote interior angles, if you take the corner where you are, the remote interior angles are on the other side of the triangle. So if you think of remote places are far away. So your remote interior angles are far away from the exterior angle. So just take the corner that you're at and get rid of it, and you've got the other two corners. And those are the remote interior angles. Does that kind of make sense? So what we have is we have a theorem that combines stuff. So what you have is that the exterior angle of the triangle So, angle 1, that was our original exterior angle, is equal to the measures of angle 3 plus angle 4. So, if you take the two inside angles and you add them together, you get the outside angle. And here's why that works. The whole triangle is 180, okay? 2 plus 3 and 4 equals 180. 2 plus 1 also equals 180 because it's a linear pair. So that means 1 has to be the same thing as 3 and 4 together. Because I'm adding 2 to each one to get 180. Does that make sense? So that's why that works. And it's a shortcut because if we look at a problem like this right here, and I want to find the missing angles, the long way would be to take this triangle, use these two angles to find the missing corner, and then use the linear pair theorem to find angle 1. But I don't have to find this, it takes a step away. This theorem takes a step away. I don't have to find this corner angle, I can just find angle 1 using the theorem. Angle 1 is equal to 70 and 55 added together, because they're on the other side of the triangle. Does that make sense? So, that's for angle 1, yeah. So I can take the exterior angle and I can add the two on the other side together. And then angle 2 is 55 because of vertical angles. So this is 55. And then there's two ways I could get to angle 3. I could find this corner angle right here by subtracting from 150 and then use the 180 thing. But the shortcut is to use this theorem, and I can say that 150 is equal to 55 plus angle 3. So to find angle 3, I just have to subtract 55 from 150. Does that make sense? So angle 3 is going to be 150 minus 55. So, and then I don't have to find those other unlabeled angles. So it just takes away a step, basically. It's a shortcut. But if you don't remember the theorem, you can still get to the answers using the 180 degree and a triangle thing. It's just this way you don't have to do as much work. And yes, that's the technical name, 180 degree of triangle thing. So, okay, bigger, gianter, triangle conglomeration. Again, technical term. Bigger, gianter, because that's a real word, because I just used it. So. Angle 1 is an exterior angle, and it's exterior to this remote side. Is that a 60? Can't see very well on the board. Is that 6? Okay. So angle 1 is going to be 80 plus 60. So 1 is equivalent to these two added together. So 140. And angle 2 forms a linear pair with angle 1. So those two together would be 180. So angle 2 is going to be 180 minus angle 1. So angle 2 is 40. And angle 3 is remote interior with angle 2 from 105. So 105 is equal to angle 2 plus angle 3 together. And angle 2 is 40. So find angle 3. I'm going to take that 105 and subtract 40 from it. Get 65. And angle 4, let's see. Angle 4 and 105 together will make 180 together. So to find angle 4, I'm going to take away the 105 and get 75. Get too many colors in here. Oh wow, that's way more than I thought. Okay. And then angle 5 is angle 4 plus angle 40. So angle 4 was 75. So angle 5 is equal to 75 plus 40. So that's 115. Did that make sense? I went through it a little fast. Do you want me to label it back again since I accidentally erased the whole thing?
For angle 4, you don't subtract the 180 minus 40
Here?
because it's his interior.
No, angle 4 is, see how this makes a linear pair right here?
Oh, okay.
So you're going to use the 105 and the 4, so 105 from 80, 180. Any other questions on this one? And again, I use the exterior angle theorem, but you don't have to use the exterior angle theorem. You could get to this using the fact that triangles are 180 and the vertical angles and things. So there's more than one way to get to it. You can use, if you don't remember exterior angle theorem, you should be able to use triangles are 180, linear pairs, and vertical angles and still get to the answer for all of these. So as long as you remember those three things, you should be okay. I got it? Okay, a corollary is it's a theorem. Corollary is kind of like a PS. You come up with a theorem. So in this case, total sum of a triangle is 180 degrees for the angles. And then that theorem makes you come up with other things. So one thing leads to another. And so that's where we get these corollaries, is that you get a theorem and then that has a T in it. And then that theorem causes you to come up with another theorem, or two. And we have two angle sum corollaries. The first one is about the acute angles of a right triangle. Okay, so if I have a right triangle, the other two angles in the triangle are going to be acute, and they're going to add up to 90. And this came from the fact that triangles have 180 degrees, because if you have a 180 degree triangle and you take away 90 degrees, you have 90 degrees left over. So that's where this came from. So the two remaining angles will always add up to 90. And then the next one we have also comes from the fact that triangles have a total of 180 degrees. And that's that if you have a triangle and you have a 90-degree angle, you can't have another 90-degree angle because the triangle adds up to 180, and if you take 90 away, there's only 90 left. So you can't have another 90-degree angle and then still have a third angle. There's not enough angle left available. And if you have an angle that's more than 90 degrees, you certainly can't have another angle that's more than 90 degrees because if you have a 100-degree obtuse angle, there's only 80 degrees left for the whole triangle. So that's where these came from. They're kind of those things that once you start looking at the fact that triangles have 180 degrees, these followed from that and they just sort of made sense. And we can use those when you have right triangle problems with missing angles. If I look at this small triangle here, okay, D is a perpendicular intersection. So if this side is 90, that's also 90. And this is 90, that means these two are 90. So I don't have to subtract from 180. I can just subtract from 90 and do 90 minus 63 and get 27. Make sense? So they take it, it's another shortcut. It takes away, I don't have to do 180 minus 90 minus 63. I can just do take the 90 away altogether to begin with. And then the other triangle we want to look at is this whole triangle, ABC, because we have angle 2 here. And this is 90. Sorry. This top corner is 90. So 90, and then these two are going to add up to 90 because of that top corner being 90. So angle 2 is also going to be 90 minus 63. So it's also going to equal 27. And then later on, when we start talking about similar triangles, you'll see that these two triangles, like a 90-degree triangle with another 90-degree right triangle with a right triangle inside of it like this is a similar triangle thing. Well, they're special. But for now, you just use the fact that this is a right angle to know that the rest of the angles are going to be 90, so you don't have to subtract from 180.